All right, young folk, today we are going to discuss medians and altitudes. We usually do more with medians than altitudes. You just need to know the difference between the two. I'll talk about medians and a little bit about altitudes. I've just been looking at some of the work for altitudes, and it's very little work out there. So this page becomes very important to know the definitions of the words. A median of a triangle. The median of a triangle is a segment from the vertex to the midpoint of the opposite side. Okay, so that is what a median is. Centroid. Point of concurrency, we talked about that, where three or more lines meet. A point of concurrency of three medians of a triangle is a centroid. So when these three meet, they call it a centroid. Now an altitude of a triangle is a perpendicular segment from the vertex to the opposite side, or a line that contains opposite side. Okay, so the difference between a median and an altitude is a median comes from a vertex. You know, a triangle has three vertices. Okay, so 1, 2, 3. A median comes down from the triangle and hits the midpoint to where it separates the triangle into two equal segments on each side. Something like that. Well, I'll show you on the next page. An altitude drops down from a vertex, but it makes a perpendicular intersection. So it's not always, or it won't be at the center of the dividing part where it cuts it into half. It's just going to make a perpendicular intersection. And all the altitudes intersect at what's called the orthocenter. So let's take a look at the centroid a little bit. All right. Concurrency of medians of a triangle. Now, I said centroid, but yeah. The medians of a triangle intersect at a point that is 2/3 of the distance from each vertex to the midpoint of the other side. Okay, so what this is saying is that each one of these medians, these are medians. How do I know that they are medians? Because the bell is ringing and the bell is interrupted. Now, I know these are medians because from vertex A, it intersects this side, BC. And you see how those two right there are congruent? From vertex C, this crosses over and intersects side BA. And you see how those two sections are congruent. And from vertex B, we intersect this side over here, AC. And you see how those two sections are congruent. So each one of these are what are called medians. Okay? And so the rule here, this theorem is stating that this first section, from the vertex to this centroid here, from the vertex to the centroid, from the vertex to the centroid P right here, that is AP, or this section here, equals 2/3 of the whole thing. That's the math. That's the equation you need to remember. PC, or CP, equals 2/3 of the whole thing. Again, BP equals 2/3 of the whole thing. Now, a little add on to that, if AP is 2/3, what would PE be? That would be 1/3. The whole thing would be 3/3, or 1 whole. So if this is 2/3, that makes this 1/3. But they don't really talk much about that in this theorem, but you can kind of put those pieces together. And so what you can kind of think about it like is this. The longer section equals 2/3 of the whole thing. A lot of mistakes that people make is they say this equals 2/3 of this, of that second part. No, it's AP equals 2/3 of AE. BP equals 2/3 of BF. CP equals 2/3 of CD, as what is stated right here. So with that in mind, let's take a look at this example right here at the bottom. So in this example, in triangle FGH, M is the centroid. Okay, so we know that's important. We know that M is like the P up here. GM equals 6. Find ML and find GL. Okay, so you want us to find this section right here and then the whole section. Okay, so looking at this example here, what do we know? The rule here says that GM equals 2/3 of ML. That's the rule. GM equals 2/3 of ML. Okay, so let's substitute what we know. We know that GM is 6. And so I'll put 6 in for GM because I don't know what ML is. And I'll just keep it like that. But can I solve for ML? Sure I can. If I multiply by the reciprocal, which is 3 over 2, to both sides, then I cancel out the fraction there. And so all I have left is ML equals 9. So ML equals 9 by solving for ML, just by substituting. Now, ML equals 9. We need to also find GL. Okay, so GL is this whole thing. Ooh, I did this wrong. Caught my mistake. I put the wrong variable in here. Do you know which one it is? This should read GM equals 2/3 of GL. This should read GM equals 2/3 of GL. Okay? GL is the whole segment, not ML. I'm still going to get the same answer when I substitute 6 in, but I used the wrong information there. And I'm not going to change this and erase it because it's a good learning issue. I said it earlier. This is the mistake that a lot of people make, or this is a mistake that a lot of people make here. And so as I multiply by the reciprocal, you'll see that I'll get the same answer. But this is saying that GL equals 9 instead of ML. That's the real thing it's supposed to say. So the whole thing equals 9, right? So if this part is 6, what is this part if the whole line equals 9? That's right. GL equals 9 and ML equals 3. Why? Because 6 plus 3 equals 9. So the whole thing equals 9. This part is 6 and this part is 3. So this would be my answers for both of those. And again, up here was a mistake, not because I did my math wrong, but because I put in the wrong segment there. It would have caused you to get one of these two answers incorrect. Okay, let's look at this example here. Suppose that FM equals 10. Okay, so this part equals 10. Find MK and FK. MK and FK. Alright, so what do we know based on this? We know that the rule says FM, oops, should have been capital M, but FM equals 2/3, let's not make the same mistake, of FK. Okay, so this segment equals 2/3 of the whole thing. Alright, so what do I know? I know that FM is 10. Sometimes you may know this one. Let's substitute what you know. 2/3 FK. You multiply again by the reciprocal, which is 3 over 2. And you get FK, because that cancels out, equals 15. Alright? So we know what FK is. So the whole thing is 15. If the whole thing is 15, excuse me, if the whole thing is 15, and this part right here is 10, what does that make MK? MK has to be 5. So we got 15 and 5. FK, 15, MK, 5. And there you go. You got your answers there. Alright? Now notice we didn't talk much. Well, I guess it's on the other page because you couldn't see it. We haven't talked much about the altitude of a triangle, and it kind of shows up from time to time. Not often. An altitude of a triangle again is a perpendicular segment from the vertex to the opposite side, and I was looking for problems that dealt with the altitude. I just haven't come across many yet, and they just usually talk about the differences between what is altitude or median. The thing to know is that when it drops down, it intersects and makes a perpendicular, And a median, when it comes down from a vertex, it bisects it. It cuts it into two equal parts. Okay, if I come across some other good stuff, I will let you know on the altitude. Merry Christmas.